Welcome back to another episode of Math Tutor Takes the SAT. I'm your host, Connor, and today we're going to tackle questions 13 through 18 of the first module of Test 1. You can download the test by visiting the link in the description below. All right, question number 13. Vivian bought party hats and cupcakes for $71. Each package of party hats cost $3 and each cupcake cost $1. If Vivian bought 10 packages of party hats, how many cupcakes did she buy? Pause the video and see if you can solve this one. So the first question that you should ask is, well, we know how many packages of party hats she bought. So how much did she spend on party hats? We can take that away from $71 and figure out how much left she had over to spend on cupcakes. All right, so how much did she spend on party hats? If each package of party hats cost $3 and she bought 10 packages of party hats, that means 10 times 3, 10 packages times $3 per package will get you $30. So she spent $30 on party hats. So how much did she have left over? In other words, how much did she spend on cupcakes? Well, she spent $71 in total. If you take away the $30 she spent on party hats, then she's left with $41. And since she only bought party hats and cupcakes, that means that she spent $30 on party hats and $41 on cupcakes. So now, the only thing left to do is answer this question: how many cupcakes did she buy? Well, each cupcake costs just a single dollar. If she spent $41 and each cupcake costs $1, then we can divide 41 by 1 in order to get how many cupcakes. In this case, it's just 41 cupcakes. So the answer is 41. All right, question number 14. We get this equation, z squared plus 10z minus 24 equals 0. Then the question asks, what is one of the solutions to the given equation? And this is not a multiple choice question. We have to give an answer. And if there are multiple solutions, then they'll accept one of them. So pause the video and see if you can figure out the solution. All right, so we've got an equation, z squared plus 10z minus 24 equals 0. So I want to remind you that one way that you can approach these problems is by graphing whatever has the variable in it. So we've got an expression that has a variable in it, and that's equal to some constant number. And the way that you might set this up is something like this. Let's replace this z with an x because we're used to x and y. Some graphing calculators only support x and y. So let's change our variable from z to x and write x squared plus 10x minus 24 equals 0. All right, and remember, to graph something like this, it's usually in the form y equals. So instead of saying equals to 0, I'm just going to say y equals this. All right, and once we have it in this form, we can plug in values for x to see what the y coordinate would be. If we plug in 0, for example, we would get 0 squared plus 0 minus 24. So 0 plus 0 minus 24 is just minus 24, and that would be the y coordinate. And that would look somewhere down here at minus 24. We'll say this is minus 24 on the y-axis, and we would have a point at 0, comma, minus 24. 0 is the x coordinate, and negative 24 is the y coordinate. We could do the same thing for 1. If we plug in 1 here, we would have 1 plus 10 minus 24, so that would be 11 minus 24, and that's negative 13. And so we would have a point at 1, comma, negative 13, so somewhere like around here. Now, eventually what's going to happen is you're going to have enough points in order to make something that might look like, I don't know, something like this. I don't know if that's what it's going to look like, but the graphing calculator is going to tell us exactly what that graph looks like. And then once we have that graph, remember that we want to solve this equation. We want to figure out where is this expression, x squared plus 10x minus 24 equal to 0. And since we're making that the y coordinate of our graph, we want to figure out where on our graph is y equal to 0. So we would find this point and this point. And those would be what we call our zeros, because the y-coordinate is 0 here and the y-coordinate is 0 here. Now let's see what this graph actually looks like. I'm going to delete this because I don't know if that's what this is going to look like. We just did a couple points and then made some parabola through them. So let's actually go to Desmos and plot this. And I'm going to plot the y equals version of this. So y equals x squared plus 10x minus 24. All right. We can zoom out a little bit. We get a better view of this parabola. It opens upward because the leading coefficient is positive. In other words, the number that's beside the x squared, it's like a 1 here, for example, that's positive, so the parabola opens upward. But we can actually figure out, what was the question even asking again? It's what is one of the solutions to the equation where it equals 0, where the y-coordinate equals 0. So let's go back to the graph and figure out if we can see where the y-coordinate equals 0 here. I see 2 spots, and Desmos is actually going to put gray points right on those spots, and we get some pretty nice numbers for those. All right, now which number are we interested in? Because this says 2, 0. Do we want to put the 2 down as a solution, or do we want to put the 0 down as a solution? Well, 2 is the x-coordinate. 2 says 2 is what you plug into x in order to make this x squared plus 10x minus 24 all equal to 0, because 0 is the y-coordinate. If you plug in a 2, everything becomes 0. So the solution is 2. Similarly, there's another solution, another number that you can plug into x up here in order to make all of this equal to 0. And that solution is negative 12. Now we said that was what the value of x was. Remember that we replaced z with x, so we're solving this equation. So z equals either of those solutions that we listed. So 2 or z equals negative 12. Either one of these is fine. You could put 2 or negative 12. Don't try to put both, but choose one of them because it asks for one of the solutions. All right, so that's how to do it pretty easily using the graphing calculator. I do want to give you an alternative algebraic solution using factoring if you're interested in that. All right, remember how I said the leading coefficient of this was 1? This factoring technique is going to work when the leading coefficient is 1. Remember that the leading coefficient is the number that's multiplying the highest degree term of the polynomial. This one is the highest degree because it's squared. It's a 2 here for the exponent, which is greater than all the other exponents. All right, so the process for factoring this looks like this. We have z squared plus 10z minus 24 equals, this is going to break down as follows. We're going to have a couple pairs of parentheses, and they're being multiplied together. And somehow, this is going to equal this if you multiply all of these out, if you FOIL it out. Well, what goes inside the parentheses? There's going to be a z here and a z here. Remember, when you FOIL this and calculate the first terms multiplied together, you're going to get a z squared because z times z is z squared. So that's where your z squared is going to come from. But then to get this 10z and this minus 24, you've got to have numbers here. All right, and so what are those numbers? Well, there could be a plus or a minus sign here. We need to decide which one of those it is. But there's going to be a number here and plus or minus a number here. And we're going to decide later about this plus or minus. All right, so how do you get these numbers? Well, you take this last term here, the constant term, the term that doesn't have a z beside it, and you write down all of its factors. Factors of a number are just two numbers that multiply together to get you that number. So 24, you can get a few ways. You can multiply 1 and 24 together and get 24. You can multiply 2 and 12 together to get 24. You can multiply 3 and 8 to get 24, or you could multiply 4 and 6 to get 24. And 5 doesn't go in, and then we get back to 6, so then we would just be wasting time going 6, 8, 12, 24. We've listed all the factors. All right. Now keep in mind that these need to multiply together to get negative 24, so one of these has to be negative. In other words, one of these is going to be positive and one of these is going to be negative, and we'll have to figure out which one that is. Now we've got a bunch of options here, but how do we know which pair of numbers we put in the blank? Well, here's the trick. They have to add up to be 10. But remember that I said one of these numbers has to be negative and one has to be positive. And when you add a negative number with a positive number, what you're really doing is subtracting. So really, these numbers have to subtract to be 10 in this case. All right, so can you subtract 24 and 1 to get 10? No, you would get 23. All right, so that doesn't work. Can you subtract 12 and 2 to get 10? Yes, you can. 12 minus 2 would get you 10. So really, we're going to have to make the 2 negative here. If we made the 12 negative, then we would get negative 10 when we add the 2 with the negative 12. All right, so the 2 has to be negative, and we can put them in any order. We'll put the 2 here and the 12 here. The 2 is negative, so we're going to make this sign negative, and the 12 is positive, so we're going to make that positive. All right, now that we're done with that, what we can do at this point is actually check ourselves to see if we factored this correctly by foiling this out. FOIL, remember, FOIL stands for first, outer, inner, last. So let's multiply the first terms together. This gets you z times z, which is going to be z squared. The outer terms are going to be this z times 12, and that's going to get you 12 times z, so plus 12z. The inner terms are this negative 2 and this z right here, and so that's going to get you minus 2z. And the last terms are this negative 2 and this positive 12. When we multiply those together, we get negative 24. Now notice, this is why these last terms had to multiply together to get negative 24, because that's how you get that last constant term, is by multiplying these numbers together. Similarly, we had to have z's here because these have to multiply together to get us our z squared. So what about this 10z in the middle? Well, if you combine like terms, 12z minus 2z's is going to get you 10z's. That's why this 12 and this negative 2 had to add together. We chose them carefully to add together to get this middle term. Because when you combine like terms, that's what happens. So when we combine like terms, we're going to get z squared plus 10z minus 24. And that's exactly what we started with. All right, that's just to check that we factored correctly. The factored form is what we're going to use to solve this equation. All right, so now let's replace z squared plus 10z minus 24 with its factored form, because now we know that this is equivalent to this. So I'm just going to write z minus 2 times z plus 12 equals 0. Now, how does this make the problem easier? Here, I encourage you to pause the video and see if you can guess two numbers that when you plug them in, solve this equation. If you thought about it for a while, you might have thought of the answers z equals 2 and z equals negative 12. Why is that? When you plug in a 2, you get 2 minus 2 here, and that's going to be 0. And you could plug it in here to z plus 12, you'll get a number, but it doesn't matter what that number is, because 0 times any number equals 0. Similarly, if you plug in negative 12 for z, then this factor is going to be negative 12 plus 12. That gets you 0. Doesn't matter what this factor is equal to, because anything times 0 gets you 0. If you have two numbers and they multiply together to get 0, then one of the numbers you multiplied has to be 0. That's called the zero product rule. So one systematic way to find these solutions is to take each factor and set it equal to 0 independently and solve those equations. So let's take z minus 2 and set it equal to 0. If we add 2 to both sides, then we get z equals 2. That's one of our solutions. Now we take z plus 12 and set it equal to 0. When we subtract 12 from both sides, we end up with z equals negative 12. And those are the exact same solutions that we got graphing the parabola. We got 2 and negative 12. All right, question number 15. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? All right, pause the video and see if you can solve this one. All right, so I think the easiest way to do this problem is think about how many times we have to double the number of cells per milliliter. It doubles every 3 hours, and so we're going to 15 hours. How many times is it going to double? Well, 15 divided by 3 is 5. It'll double 5 times. So what we can do is make a table and actually double this number 5 times. So we're going to say after blank hours in this column, and in the other column, we'll put the number of cells. It's cells per milliliter, but I'll just abbreviate that as cells. All right, at the start, what do we put here for this number? After blank hours, how many hours have passed at the very start? That's going to be 0 hours. Well, after 0 hours, or at the start, how many cells per milliliter were there? It says during an initial observation, there were 300,000 cells per milliliter. That's our starting value. So we put 300,000 here. All right, then every 3 hours, this number is going to double. So let's double it. After 3 hours, how many cells are there? 3 times 2 is 6. We've got 5 zeros here. Those are going to carry through. So 600,000. After 6 hours, how many cells were there? So 3 more hours have passed. It doubles again, and we get 1,200,000 cells. After 9 hours, how many cells are there? This is going to double again, and we get 2,400,000. After 12 hours, how many cells were there? There will be 4,800,000. All right, at this point, we're about to get to the answer. After 15 hours, we look back up here and realize that we've already eliminated A, B, and C. We could double again, and you might predict what it's going to be. It's going to be 9,600,000, but we could just go ahead and say D is the answer. All right, which expression is equivalent to 6x to the 8th y squared plus 12x squared y squared? Pause the video and see if you can solve this one. All right, so this one is going to involve factoring, distributing, and exponent rules. So let's talk about each one of those with a warm-up. So for a warm-up question, I want you to expand 3x times 2 plus y. So this expression is 3 times x times 2 plus y. When you expand this, what do? You take this number, 3x, and you multiply it first by 2, and then you add this number multiplied by y. That property is known as the distributive property. Multiplication distributes over addition. So when we expand this, this is equal to 3x times 2 plus 3x times y. This is super important, so make sure you memorize this fact. We can rearrange these factors over here. These numbers are glued together by multiplication, so we can focus on them. 3 times x times 2, we can multiply in any order, so we might as well just say 2 times 3 times x. Plus, let's focus on these numbers, glued together by multiplication. 3 times x times y. There's not really any rearranging to do here, so you just write 3xy. Since we're multiplying numbers in any order we want to over here, we can multiply the 2 and the 3 first, and we get 6x plus 3xy. And that's how you expand an expression with the distributive property. We like to call this multiplying through. All right, now we're going to warm up with a second problem. That second problem is factor 6x plus 3xy. You might notice this from somewhere. It's this right here. We're about to go in reverse. We're about to factor out this 3x that we multiplied through when we expanded this. So let's try that out. So when you're factoring, what you want to do is you want to see what can you divide both terms by. You can divide both terms by, well, we've got a 6 here multiplying the x and a 3 here multiplying the xy. We can divide both 6 and 3 by 3. So we're going to write a 3 here. That's going to come out because a 3 can go into this and a 3 can go into this. Now, what else can we pull out? Well, we can actually divide by x because we've got an x multiplying this 6x here, and we've got an x multiplying this 3 and y here. So we can take an x out as well, so we'll do that. Then we're going to write our parentheses. Remember, we're reverse distributing. We're undoing all this process here. Well, since there's a plus here, we're going to have a plus inside our parentheses, and then I want you to think what two terms go inside the parentheses so that when you distribute the 3x through, you'll get back here where we started. Here's what I mean by that. For this term, what would you multiply 3x in order to get 6x? Because that's what this times this is going to need to equal. If you said 2, you would be correct. When you multiply this 3x with the 2, you'll get the 6x that way. Now what about this term? In order to figure out this term, you're going to need to ask yourself what would go here so that when you multiply 3x with that term, you'll get 3xy. And it's actually not a number that goes there, it's a variable, the variable y. So if we put a y here, then 3x times this y here will get us 3xy. That's what we got when we practiced expanding this with the distributive property. So the important thing to take away here is that factoring is the distributive property in reverse. All right, now there's one more thing you've got to know in order to be able to do this problem. In the warm-up problems I gave you, there were no exponents. Here it looks like we've got exponents on x, y, x and y here. We've got to figure out a way to handle those exponents. So let me teach you a rule about exponents that's really useful. You should memorize this. What is x to the third times x to the fourth? Well, in order to figure this out, we've got to understand what an exponent actually means. Well, an exponent means that it's 3 copies of x multiplied together. So this x to the third is just x times x times x. And all of this is going to be times, so another times, x to the fourth. Well, x to the fourth is just x times x times x times x. And if we look at what we've got here, we've got 7 x's total multiplied together. So what is this equal to? Well, we could simplify this as x to what power? If you said 7, you'd be right. This is x to the 7th power. So what's the rule here? If you've got x to the power of a times x to the power of b, then that is x to the power of whatever this is plus whatever this is, so a plus b. And now we finally have enough ammunition to tackle this problem. So if you look at all these answer choices, we have what we took out, and then we've got parentheses. For each one of these answer choices, we've got something times a pair of parentheses. And that should tell you maybe factoring is going to play a role here. So if we want to factor this, we've got to figure out what do we take out of this? In other words, what are we going to be able to divide both of these terms evenly by? So let's just consider the 6 and the 12 first. I'm going to rewrite this expression. 6x to the 8th y squared plus 12x squared y squared. So what can we take out of the 6 and the 12? Well, both the 6 and the 12 are divisible by 6. So I'm going to write this equals 6. And then, what can we take out of x to the 8th and x squared? Well, here there are 8 x's multiplied together. And here in this term, there are 2 x's multiplied together. So we can only divide by 2 x's. So we're going to divide by an x squared. For the y's, we've got a y squared here and a y squared here. So we can actually divide both of these by y squared. Then we're going to put our parentheses, and this is going to make more sense when we think about what goes inside the parentheses. There's a plus here, and we didn't factor out a negative, so this is going to remain positive. Then we want to think, what is each term going to be? How about this term? We need to figure out what goes here in order to make it so that when we multiply this with this term, we get 6 times x to the 8th times y squared. So what goes here? Well, we don't need to multiply the 6 by anything to make it 6. We do need to multiply the x squared by something in order to make it x to the 8th. What would we multiply it by? Well, x squared times something would equal x to the 8th. And it's x to some power. Remember that these exponents have to add up to be 8. So this exponent needs to be a 6. So that's what we would multiply this whole thing by in order to get an x to the 8th here. We need an x to the 6th here. How about this y squared? Do we need to multiply anything with this y squared to get y squared? No, it's already y squared. So we're actually done with this term. How about this term? To figure out what this term needs to be, we need to imagine what do we put here that when we multiply it with 6x squared y squared, we get this last term here. We get 12x squared y squared. All right, we're gonna need a number that when we multiply this 6, we get 12 here. So we're gonna have to have a 2 here at least. What about this x squared? Do we need to multiply anything with this x squared in order to get this x squared? We're done there. What about this y squared? Do we need anything to get this y squared here? No. All right, so we're done. And to check our work, we can multiply this out and see if we get what we started with. When we multiply this out, it's gonna be 6 times x squared times y squared times 6 times x squared times y squared times x to the 6th plus 6 times x squared times y squared times 2. 6 times x squared times y squared times 2. When we rearrange these factors here, we can multiply the x squared with the x to the 6th, like so. When these multiply together, remember that exponent rule that I taught you. You add the exponents together. So that's just going to be 6x to the 8th y squared. Plus, we didn't do anything with this. When we reorder this, it's going to be 2 times 6 times x squared times y squared. We multiply the 2 and the 6 together, and we get 12x squared y squared, which is exactly what we started with up here. And the main result of this is what we got when we factored. If we look back to the answer choices, there's one of these answer choices that exactly matches what we came up with. And that answer choice is C. And that's our answer. Now, if you find factoring confusing, there's a trick that you can do. It takes maybe a little bit more time or a little bit less time depending on your skill set. So since this is multiple choice, only one of these can be right. Let's expand all of these and see if they equal this. So now we're gonna, instead of factoring to get from here to here, we're going to expand each one of these answer choices to try to get from here to here. So we'll do each one of these separately. All right, let's expand this. So answer choice A says 6x squared y squared times 2x to the 6th. Now here, we wanna be careful. We don't distribute to here and to here. We only distributed when there was a plus in the middle of these two. So if there's a plus in the middle of these two, then we distribute. There's no plus, so we don't distribute. Really, this is all multiplication. We've got a 6 times an x squared times a y squared times a 2 times an x to the 6th. These parentheses here say do this first, but really, does it matter what order we multiply all these in? It really doesn't. So we can remove these parentheses and put a dot here to say that this is y squared times 2. All right, we've got 5 factors multiplied together. We can rearrange them in any order we want to. So I'm going to rearrange the 6 and the 2 to be next to each other. 6 times 2. I'm going to arrange the x squared and the x to the 6th to be next to each other. So x squared times x to the 6th times y squared is the only thing we have left. All right, and when we combine like factors, I guess, we get the 6 times 2 multiplied together to get 12, the x squared times the x to the 6th to get x to the 8th, and just the y squared left over. So this, answer choice A, equals 12x to the 8th y squared. And that is not this. Answer choice B says 6x squared y squared times x to the 4th. Now, again, don't be fooled by these parentheses. This is just 6 times x squared times y squared times x to the 4th. We can rearrange this multiplication in any order we want to. Let's say 6 times x squared times x to the 4th times y squared. And I'm going to multiply the x squared with the x to the 4th first and get 6 times x to the 6th y squared. That is not this either. So we move on. Let's multiply out answer choice C, which we already know is the answer. 6 times x squared times y squared times x to the 6th plus 2. Now that we have a plus here, we use the distributive property. So we take 6x squared y squared, multiply it with x to the 6th, plus 6x squared y squared multiplied with 2. Let's do that. So 6 times x, so this equals 6 times x squared times y squared times x to the 6th plus 6 times x squared times y squared times 2. Let's rearrange these factors. I'm going to start with these factors. Let's say 6x squared x to the 6th y squared plus, I'm going to write the 6th and the 2 next to each other, 6 times 2 times x squared times y squared. And that's going to equal, we're going to multiply these out. So we get 6x to the 8th y squared plus 6 times 2 is 12, x squared y squared. If we look back up here, this happens to match exactly. You might need to reorder things if you had something in the reverse order here and you didn't reorder it right, then you might need to do a little bit of reordering, but compare it to this and you should see that when you reorder, it's exactly this. And that tells us that the correct answer is C. All right, question number 17. A neighborhood consists of a 2-hectare park and a 35-hectare residential area. The total number of trees in the neighborhood is 3,934. The equation 2x plus 35y equals 3,934 represents this situation. Which of the following is the best interpretation of x in this context? Pause the video and see if you can solve this one. All right, so I guess it helps if you know what a hectare is. You don't necessarily need to know what a hectare is, but a hectare is a measurement of area, kind of like square feet or square meters or acres. All right, so I'm going to draw a 2-hectare park. Let's say this is the first hectare and this is the second hectare. I'm going to draw an average of, let's say 1, 2, 3, 4, 5 trees per hectare. Because if we look at the answer choices, we've got the average number of trees per hectare in the park, the average number of trees per hectare in the residential area, the total number of trees in the park, and the total number of trees in the residential area. So let's play around with this idea of trees per hectare. So in this example, we've got a park with 5 trees per hectare on average. If you wanted to find the total number of trees in the park, what you could do is take your average rate, your 5 trees per hectare, and multiply it by the number of hectares in the park, by the size of the park. There are 2 hectares. When we multiply the units together, something really important happens, and something that you really have to remember. The denominator of this rate is going to cancel out with hectares over here, and you're left with the unit trees. So when you multiply this out, you get 10 trees. And that makes sense because we've got 2 hectares, 5 trees per hectare, and so 10 trees total. So now let's take a look at this equation that they give us. So the equation says 2 times x plus 35 times y equals 3,934. Well, one number that jumps out at me is this 3,934. If we look at the problem, that is the total number of trees. So if we put units by all these numbers, we put trees by this quantity here. 3,934 trees. All right, now let's think about what this 2 and this 35 represent. If we go back to the problem and we scan the problem for the numbers 2 and 35, because where did these numbers come from? Well, this 2 came from, looks like this 2-hectare park number. So this is the size of the park, and this 35 number is the size in hectares of the residential area. So if we put units by this 2 and this 35, now we can rewrite this equation as 2 hectares times x plus 35 hectares times y equals 3,934 trees. So now let's address the question. The question is, which of the following is the best interpretation of x in this context? Let's start with answer choice A and see if that's it. A says x is the average number of trees per hectare in the park. And that's what we started with in this example. We started with, let's say 5 is the number of trees per hectare in the park. If we put, instead of x, we put units now, then we would have 2 hectares times x trees per hectare. Trees per hectare plus, and we could use the same approach over here and see what happens. 35 hectares times y trees per hectare equals 3,934 trees. Now let's do math with our units. Hectares is going to cancel out with hectares in the denominator, just like it did up here. And this term, 2 times x, the units of that is trees. And specifically, it's the amount of trees in where? Is it the park or the residential area? It's the park, because this 2 was the size of the park, and this x is the average number of trees per hectare in the park. So this is the number of trees in the park. If y is the number of trees per hectare in the residential area, then this, when we multiply the 35 with the y and the hectares cancel out, we're going to be left with trees, and specifically, it's the number of trees in the residential area. When we add the number of trees in the park with the number of trees in the residential area, we get 3,934 trees total. And so answer choice A, turns out it makes a lot of sense. So we're going to choose A. Why is it not B? Well, it seems like Y needs to be the average number of trees per hectare in the residential area, because 35 is the size of the residential area. It's not the total number of trees in the park, because that's 3,934. And it's not the total number of trees in the residential area. What's that? That is 35 times y. That gets us the total number of trees in the residential area. All right, question number 18. The graph shows the relationship between the number of shares of stock from company A, X, and the number of shares of stock from company B, Y, that Simone can purchase. Which equation could represent this relationship? Pause the video and see if you can figure it out. There are many ways to do this. One way is to choose any 2 points on this line and use, for example, slope-intercept form or point-slope form to plug in these numbers and figure out what the equation of the line is. But since we're given multiple options for the equation of the line, what we can do is test points to see if they fall on each one of these lines. Turns out that that's going to be a really easy way to eliminate some of these options and a quick way to come to the right answer. So let's do that. Now, which points should we choose to test? Well, it turns out that the intercepts are really easy points to test. And here's why. For this point right here, what is the x-coordinate? Well, the x-coordinate is 60 because it's 60 on the x-axis. But how far up or down is it? It's 0. Your x-intercept is always going to have the y-coordinate equal to 0, because in order to be on the x-axis, in order to be on ground level, you can't be up or down anywhere. So the y-coordinate is always going to be 0 when you're on the x-axis. The same thing, but reverse, applies to the y-intercept. Here is the y-intercept. Here we know the y-coordinate is 40 because we're up 40. How far left or right are we? Well, in order to be on the y-axis, you can't be any left or right. So the x-coordinate has to be 0. So those are our 2 points. Let's write the coordinates down. We've got 0, 40, and 60, 0. Let's try each one of these equations. Now, remember, in order for a point to be on the line and that equation to be representative of that line, when we plug in the x-coordinate for the x value and the y-coordinate for the y value in the equation, everything has to be equal. We have to have equality on both sides of the equation. So let's try that out. Our equation for A is y equals 8x plus 12. Let's try this first point. We're setting x to be 0. So 8 times 0 plus 12 on the right-hand side. We're setting y to be 40. So 40 on the left-hand side. We have to test and see, is this equal? So we're going to put a question mark over the equal sign. Well, does 40 equal 8 times 0 plus 12? 8 times 0 is 0. Add 12, that's 12. So these are not equal. This point is not on the line represented by equation A. So A is out. All right, let's try this next one. The next one is 8x plus 12y equals 480. So substitute, let's try this one. Substitute 0 for x, so 8 times 0, plus 12 times, we're substituting 40 for y. and asking, does that equal 480? 8 times 0 is 0. What's 12 times 40? Well, 10 40s is 400. 2 40s is 80, so that's 480. 480 does equal 480, but are we done? No. We have to verify that both points are on these lines because there are a bunch of different lines that could go through this point that are not this line. So this could be one of those other lines that go through this point that's not the line that we're interested in. So we do have to check this one too. Once we've checked 2 points, we know that 2 points make a line. We know we're done. All right, so let's try 60, 0. Our equation is 8x plus 12y equals 480. Let's plug in 60 for x, 8 times 60, and 0 for y, plus 12 times 0. Does that equal 480? Well, 12 times 0 is 0, so we can put plus 0 here. 8 times 6 is 48. With a 0 on the end, that's going to be 480. And that does equal 480. We verified that this point and this point are both on the equation in answer choice B. So that is the answer. Now, if you hate plugging these in, if you absolutely hate the computation that goes with this, you can do this problem in Desmos if you're careful. Let's try that. So in Desmos, when you've got x's and y's in an equation, you can just plug that into Desmos and it's going to graph that for you. So we're going to graph first y equals 8x plus 12. So y equals 8x plus 12. And what do we get? We get an equation that slopes upwards. So when you go to the right, you're increasing. When you go to the right, the graph is going upwards. If we go back to this line, we're going downwards. When we go right, we actually go downwards. So the line that Desmos just plotted is definitely not what this line is. So we can rule out A. How about B? Let's graph 8x plus 12y equals 480. 8x plus 12y equals 480. Now we gotta be careful. When we look at this graph and we toggle back to the graph here, it looks like it may be slanting a little bit more downwards. But if you take a look at the x-axis, the numbers are closer together. This 10 here is not the same length as this 10 on the y-axis, so this is gonna squish the graph horizontally a little bit. So don't be worried about that, but choose a couple points that match up. We could choose this point that looks like it goes through the y-axis at 0, 40. We want to make sure that that point is on this graph, and it looks like it is, 0, 40 here. Let's go back to the original graph. This says that we should have a point at 60, 0 on the x-axis. Let's go back to Desmos, and sure enough, we've got 60, 0. And we've just verified that our algebraic solution was right by plotting equation B in Desmos. So Desmos confirms B is the answer. All right, that's the show. Hey, if you learned something, click that like button and subscribe if you want to see more. See you next time.